Good day friends, today we are going to discuss about storage volume management in Kubernetes cluster. It is one of the very typical or critical task in the Kubernetes cluster administration because we will be mostly playing with the customer data. So as you can imagine how much sensitive and critical that particular data. So since the topic is vast and critical, our approach will be systematic. To approach in a proper systematic manner, we will segregate this into two categories. The first one is static storage volume management. Second one is dynamic storage volume management. Static storage volume management, we have to define each parameters in a specific manner and to the pod, and we have to provision the storage. At the same time, the static storage volume management, if the pod is moving from one node to the other node, there is high risk of data loss. So that in the production infrastructure, we never ever recommend this method. However, there are some useful cases. We will discuss that as well. And the dynamic storage volume management we will discuss in our next video. Let's discuss about static volume management in Kubernetes cluster. We have predominantly four methods here. One is empty directory. Suppose if you have decided to deploy a pod, that pod is exclusively for a web application which is not at all critical. In that case, or at the same time, if a lot of customers will be accessing the pod and the application team requested you to create a cache directory, and it is not that much critical. In that case, you can do one thing. You can create a dedicated directory and you can plan all the cache data to be preserved in the particular directory, so that it will not mess the default Kubernetes file system. So that particular cache data or that particular logs, whatever, it will be preserving into a specific directory that is called empty directory. As soon as the pod is removed, this empty directory also will be removed, since it is bound into the base layout of Kubernetes, that particular pod. It is as simple as, if we create a directory inside C drive, how will it? We can copy the data, but as soon as the OS is crashed, the data, we will lose the data. Or if we delete the server, the data will be gone. At the same time, in Linux also, if we create some directory in slash, the same way here in the case of Kubernetes pods, we will create an empty directory. Next is directory or file. This method is predominantly, for example, if we define a file system layout, that particular pod will have a default. If it is Nginx or Redis, whatever it is, will have a default file system layout. If you want to copy the data into a specific directory, like the empty directory, assume that if that directory is not present. So this method, what it will happen is, it will create a directory and copy the data. If it is in the case of file or create, in the sense, it will create a file and copy the data to that file. That is second method. Now the third method is host path. I would say this is somehow robust solution. If the pod is just running on one node, it is as simple as you guys knows very well, this pod will be running on one node. Assume that we have a two node cluster. One node is masternode and the second node is workernode. So here the pod will be always running on the workernode, node 2. If you create an empty directory or directory within the pod, as soon as the pod is removed, your data will lose. But in this case, you can do one thing. You can create a partition in the server, and that particular partition can be tightly coupled with this pod and a particular file system directory residing in the pod. So as soon as the pod starts pushing the data to that particular directory, The data will be preserving in the partition or the file system residing in the base machine, which is the worker node. Next is block device. Kubernetes is pretty much compatible with all the storage solutions. Most of the storage solutions, I would say, not all. Like AWS block device, it will support. Google Cloud disk will support. Azure disk will support. VMware data store will support. Even our base machines hard disk will support, or NFS will support. Provided if it is a cloud integration, yes, we have to install some specific plugins for the cloud integration, something like AWS plugins or Azure plugins we have to run on all the worker nodes. So it will be able to couple with the cloud or connect with the cloud and can transfer the data here and there. Again, I would say there's a standard, CSI standard, container storage interface standard. If I wish to be an entrepreneur, and if I started a company to design and define a storage solution, I can develop a product, and if my product meets the CSI standard, that means my storage solution can be connected to the Kubernetes cluster and can provision to the storage to a pod. So that is known as CSI standard, because the Kubernetes is an open source solution and there are a lot of standard OEM present in the market. So everyone wish to contribute or promote their product. To avoid a bug or to avoid a confusion or to avoid a lot of complex scenarios, the Linux Foundation has defined a standard called CSI. So whenever the vendor starts developing their product, first they will look at the CSI standard and they will compile their product to meet the CSI standard. That's it. So that's it about the static Kubernetes volume management provisioning. Now let's move on to the lab. One master node, which is node 1, and we have a worker node, which is node 2. So let's deploy a pod and understand that how it works. So we have pod.yaml. So guys, I will repeat this again and again because my requirement is you guys should be pretty much confident how do we create a pod using the declarative method, and these parameters, whatever the parameters, I will keep on telling again and again, maybe bored, but my requirement is it should very well fit into your mind, and whenever you wish to create a pod, it should come on your fingertip. That is my expectation, and I hope this will help you a lot. So API version is v1 in the case of pod. So what kind of object are we going to create? It is pod. So again, metadata. It's a metadata, data about the data. Here the data about the pod. We can define, it's a property. So we can define the pod name called, we will create called nginx as a pod name. Then you can label it anyway. That labeling is not compulsory for static pods. It will come into the picture when we create the dynamic pods. Now let's create a plain and simple pod. The name is nginx and we are going to define the specifications. So first, containers. image also I will put nginx. Now here our part. I told you that volume mounts. So I'm gonna create a directory under slash I would say my any name I will call, okay. It is called data. I will create it in an array because if I want to create multiple directories, so each thing should not get messed up. So I will keep these things in an array and define the values. So here it is. I'm gonna save the data. So volume mounts data where I need to mount it. So that is called mount path. The name you can put any name. There is no such compulsory or thumb rules. So I wish to create the directory under slash. So I'll mention it slash data. Then I told you guys volumes. So volumes are the devices where we are gonna mount on the pod. So device, again volume we can mention here as the same volume mount name we have to call it. Then only the cluster will understand that volume mount is one thing and this is my file system. So this together couple and the user should be able to access their data. So this way name is data. Both are in same array. Opening and closing curly brace. Alright, that's it. Now we are good to create the pod. kubectl create -f pod.yaml. I'm sorry guys, there's a typo. kubectl create -f pod.yaml. Alright, the spelling, everything is correct. Yeah, support has been created. Now let's test it. kubectl exec pod name nginx minus interactive terminal -- the command, which is I'm gonna land into the shell. So if we go df -hp, yes, we can see one slash, it is mounted, sdb is mounted. Now let's go to the slash directory and ls. Okay, we have created a data directory. So the data directory is listed under slash. Alright, let's go to the data directory. Nothing is there. Touch space test. An empty file called test is created. Alright, if I come out from here, kubectl get pods, guys, look at that, nginx pod is up and running. And let's delete that. kubectl delete pods nginx. Alright, it has been deleted now. So along with this pod, that directory also deleted. So we cannot retrieve the data. It's gone. Now vi pod.yaml again. I'll go here. The same data. Now it has mount path, right? So it has volumes. I will do one thing now. Say the name is data. Perfectly all right. I'll mention this way: host path equal to, sorry, the host path and path equal to /opt /data. Alright, now I will mention here type directory or create. We will create a pod blindly and see what is happening. Okay, I don't know what will happen. kubectl create -f pod.yaml. Okay. Error validating pod.yaml, error validating data, validation error, pod.spec volumes. Yes, under volumes there are some problems. Unknown field type. So type is unknown. What is the problem with the type? Let's see. Okay, here type directory or create. What I mean, in host path I told cluster to create an /opt data, and the /opt data should mount in the pod under /data. Make sense? So assume that the /opt is present, but data directory is not present. In that case, it will throw some error. So for avoiding that, we will put a type is directory or create. So it will check whether a directory is present. If it is not present, it will create a directory. Hope you understand that. Let's see what's happening there. Well, it has been created now. Now kubectl exec nginx -it --sh. So guys, if you look at here, you can see that overlay and it is /data is mounted. Well and good. Just hold on for a while. Now we will go to /data touch space 1 2 3 4 5 6 7 8 9 0. I have created this many files, and cat /etc password to /data. I'm sorry, cat /etc password to /data password.txt. It has been copied. Now let's see. This many files are there. I'll come out. Okay, clear. kubectl get pods, and kubectl get pods -o wide. I'm sorry, there's a typo, wide. Alright, the pod is running on the node 2. So let's go to the node 2 and see what is happening there. This is node 2. Let's go to /opt. Okay, we can see one directory called data. Also, let's see what is happening. We have 0 1 2 3 4 5 6 7 8 9 and password.txt file. Alright, so guys, you might have understand that we created a pod on node 2 and we mapped /opt data directory under /data directory in the pod. So whatever the data is copying into the /data, it is saving in the directory under /opt data on the node 2. Remember the worker node 2. Okay, now let's go back to the master node. Here kubectl delete pods nginx. Okay. kubectl delete pods nginx. That nginx pod has been deleted. Well and good. Now I will go back to now I am at the node 2. If I see, I have this many data, right? No, node 2. Let's see /opt/data. Yes, there are multiple empty files as well as the password.txt file which we have copied earlier. Everything is present. Now let's go back. Let's go back to the master node again and see. kubectl get pods. There is no pods present. Now we have one more thing, right? pod.yaml. Let's assume that I have changed everything. I'm gonna create a Redis pod. Redis pod, and the image will be Redis. Remaining data, mount path, everything remains as it is, or leave it. I will create something different. Redis db, and here also I have to mention that db. Here I have to mention only db, because in the case of Redis or any other thing, I have changed the mount file system layout, right? I have changed that log or data earlier, whatever it was present. Now I changed that mount point to db. So it will be a directory will create under Redis file system layout /db, and the /opt data will be mount under /db. So whatever the data present in the /opt data in the worker node will be able to access from the pod under /db. Let's look at. Clear? Okay. kubectl create -f pod dot -f pod dot yaml. It has been created. Fine. Guys, remember I haven't changed the name, right? Okay, pod dot yaml, so that the name remains same, but the image will be Redis. Just remember that in the mind. So kubectl exec pod name is nginx as it is -it -- space sh. I'll be landing into the shell. All right, guys, look at it. We have /db. Let's go to /db. What is there? Yes, everything is present as it is. Correct. So let's exit from here and kubectl delete pods, then nginx. I have deleted the pod nginx. Alright, it is taking time, no worries. Fine. Now we have created a directory called db. Now pod.yaml, let's go inside once again. There is one more option called subdirectory or subpath. Assume that, guys, you have a directory called log messages, right? I'm gonna run a pod called nginx, and the image is called again nginx. Then I will have a mount point called web. Then I will do one thing, I will have a mount point called again /web. Then I will create some more thing under /web. I need some more thing. Alright, so name, I will call it as again web. Mount path will be /again web / I will say HTML. My HTML data will be residing under /web /HTML. So I have to define a subpath for that. Subpath means it will create a directory inside that particular mount path. So here it is, /web is the master directory. Under /web I will have web, under /web I will have HTML directory. So subpath is like a HTML again. Now I will go here, name again web. I have a mount path called /web / here it is HTML, here it is users. Now I'll create a directory called or subpath called users. Guys, remember that what you are mentioning here, the subpath, everything should be here as well, because it should create a directory under web. Just keep that in mind always. Now we have one more thing, name web mount path /web /logs. Alright guys, now everything has been mapped perfectly, and we call it from here, it is web. Where it will mount? It will mount under /opt data. Now let's look at what is gonna happen. Okay, kubectl create -f pod.yaml. Guys, before that let's do this. Kubectl get pods. No pods are running, fine. So kubectl create -f pod.yaml. Nginx is created. Kubectl exec nginx -it space sh. Alright, df-h. We have a directory called /web. Let's go inside /web. What is there? Perfectly alright. If you look at here, again, earlier we had created a data /opt data, that particular directory under the node workernode, node 2. Now what happened is, we have a master directory called /web, and within the /web we have subdirectories called HTML and logs and users. So what happened is, a dedicated directory has been created inside the pod, as well as the specific data will be present in the worker node. So if the pod is deleted as well, we can retrieve the data from the directory present in the worker node. Let's verify that whether it is true or not. So worker node is node 2. Remember guys, so So we will go to the worker node here, cd/opt. Let's see what are all these. Data is there, fine. Alright, now we have three directories called HTML, logs and users. This method is called subpathing. So that's it from our side now. Before that, let's do a cleanup process. Then we will recap and wrap it up this session. kubectl delete pods nginx. The pod has been deleted. Now we have to come to the worker node again. cd/opt ls. We have data directory cd/cd data ls. This many things are present, so let's go back and delete data. All right. So no ports are present. Let's see rm -rf. pod.yaml. So this concludes our session. Guys, we left one topic, that is basically the block device. So block device, how do we define it is as simple as in the volumes, under volumes, whatever we mentioned here, under volumes we defined -name cache volume, or we define -name space data. The data would be as it is, and in place of type or host path we have to use the right plugin. For example, if it is AWS, we have to define AWS EBS block colon that particular path to the AWS EBS block, or Google persistent disk in the sense GCP disk colon that exact attribute will be available in the Kubernetes documentation. So there is no rocket science in that. We can just refer that document, select the right attributes like AWS EBS block or Google disk or Azure data disk or Azure file, and then map that or copy paste that particular path. And once the path is copied, automatically the data will start copying to that particular path. Now remember this, if you have node 1 or node 2 or node n, if you wish to use the cloud solution, remember that you are copying or you have already installed the cloud adapter with respect to the cloud solution provider, so that it will automatically establish a connectivity in between your worker node and the cloud data center. So as a result, you would be able to copy the data, else you will see a disk mapping error while creating the pod. And if you haven't create a pod without a proper connected data device, pod will be created, but the data will not be mapped to the cloud. So it will be created locally, data will be copied locally. As a result, you will lose the data. Make sure your data is perfectly being copied to the cloud or your block device or NFS, wherever it is. Again guys, I told you that we have an NFS. If we have NFS, that NFS directory should be mapped or exposed to if we have n number of worker nodes, to all worker nodes, and each worker node should have a specific directory. In that case, if the pod is moving from one node to the other node, this same particular directory will be mounted over there as well, so that it will be in an synchronous manner, so there will not be any data loss. Else, assume guys, we have a directory present in the node 2, and we have another worker node 3. If the pod is moving to node 3, automatically a directory will be created in the node 3 and freshly collected data will be saved there, so that the delta will be missing. So if it is a normal website details and all, we can copy it. If it is an SAP solution or a database solution and all, this data will be functional data. So the delta data cannot be clubbed together. So that as a result, it may lead to a data corruption. So remember these points, guys. And I just created a simple symbolic layout of the structure. This is our base worker node, and this is basically empty directory. So this empty directory, assume that this is a pod on the node, and this is our empty directory, and this empty directory will be vanished if we delete the pod. And this is the host path. This is assume that these partitioning are the Linux file systems. So we have selected one among them, and that particular file system is tightly coupled with this particular pod and particular directory in the pod. So the data will be collecting in this particular path, and it will be preserving in the file system, specific file system on the host path. Same way, we have a block device. The block device, if it is /sdx or multipath device, whatever it is, that particular device can be mapped to the pod. So the data will be residing in that particular block device. Similar way, the block device can be exported from what we say a cloud solution like AWS, as I told earlier. The same thing also can be mapped here. So that concludes our today's session. So guys, I request you to practice this well and let us know if you have any doubt. In our next session, we will be deeply discussing about dynamic storage volume provisioning. I believe this is a useful session for you, and if you have any doubts, concerns, please comment in the comment box. Definitely I will be answering to your questions. And the one more thing, I would strongly recommend you to refer the Google Kubernetes documentation, so that will help you to be more familiar with the storage modules and what are all the various storage solutions or products that supports Kubernetes. Thank you guys for your time, and have a great day.